Okay, so now that I'm back, um, I want to share two things. I wasn't able to figure out why is it that I can't write on the final equation quiz or the sheets that I pull up the way I once could. So I'm still working on that. But I am able to go to the whiteboard and do a pretty decent job of explaining what we're going to be covering today. But before I do that, I want to do a little survey. And although I'm not sure if the university actually surveyed the students on the efficacy or the effectiveness of teaching in this method, what are your views? And I know that sometimes students are reluctant to share, but I can assure you that everything you type in will just be used to improve our mode of delivery for our students. As a professor, I want to always do the very best that I can in whatever environment I am afforded. So, of course, this summer, I had no choice in us being forced to use this online teaching method. It doesn't mean that it's my preference, but being that we're in this situation with COVID-19 and the spread of the disease and all that, this is all that we were left with. But I still want to know how you feel about online teaching. So you can tell me in just a few words if you think that it allows you to learn as well, or you don't learn as well, or you like it better because you have the flexibility of not having to, come to a classroom, or just what, just give me a few sentences if you don't mind, what it is, and you can put it in private, what it is that you like or don't like about online teaching. I want to have just a few comments so I can sort of um, evaluate what we as faculty should know from our students going forward. So I'll give you a few minutes just to type something in. Okay, I've heard from one student, and I agree that hands-on, face-to-face teaching, I think, is more effective. But uh, I do like the fact that some people have had a good experience online. I think that most people do prefer face-to-face traditional teaching, especially when you have the human interaction that that is just just a part of being in the classroom. But personally, for me, I like the in classroom teaching. But I'm hoping that we were able to provide something for you this semester. Okay. All right. Well, thank you for your comments. And with that being said, we're going to move forward. As I was structuring the exam, I thought about a couple of things. I thought about what I really want to assess. In other words, I thought about what are the main points that I hope that you all gained from this chapter, from this course. And in doing that, I was forced to go back to the earlier chapters. And although I said that I would not be reviewing that, I do want to pull up a couple of items that I want to just make sure that you all have mastered. So with that, I want to show you a couple of pages. First, I'm going to pull up the midterm exam review that we did before the midterm. Okay. So here in this chart, do you recall what is the basic idea behind this chart? Who can tell me what was the basic idea behind this chart you see in front of you? There are several things on this chart. I just want to know if you can pick them out. But so let's go to chat and tell me, what am I trying to focus on in this chart? Anyone? What am I trying to focus on in this chart? Please give me some comments. No one? No one knows the purpose for a chart like this, or what we were trying to convey in a chart like this? Okay, very good. We're using Pythagorean theorem. Okay, Pythagorean theorem refers to triangles. Very good. Okay, anybody else? Okay, look more specifically at the numbers that I've chosen here. Look at these numbers. And what else do you think I'm trying to get across? Anyone? Okay, so let me use what okay, very good. Vectors. I like that. Okay, very good. All right. Now, let me go to the whiteboard and show you something very quickly. Something as simple as knowing how to use Pythagorean theorem, how to look at and understand triangles, how to understand the three trig functions that we taught can help you to know so much. So just in that simple chart, I'm trying to help you to understand how to always interpret what is meant by the hypotenuse, the opposite, and the adjacent side when you're given a right triangle, And so, of course, we know that if we want to define the lengths of these sides, if we know either of the two, we can find the third one using Pythagorean theorem. We also know we can find this angle theta if we know any of the two using our three trig functions. But also, now that we've gone through and talked about this, we can also use this now for vectors. And somebody said vectors, because vectors have both magnitude and direction. And so just from learning this concept, I'm hoping now that this knowledge can be transferred to what we learned, say, even in the chapters on 2 and 3 dimensional motion, 2 and 3 motion, motion in 2 and 3 dimensions. So with that being said, then I want to take you to a problem that we reviewed in the exam. Okay. All right. For those who came late, earlier I asked for you to just give me a couple of sentences or so on what has been your experience in this online teaching format. I also shared that personally, I prefer teaching in the classroom. regular face-to-face traditional teaching. However, we were not afforded that due to COVID-19, so we had to proceed in the best manner that we could. But still, I want to be able to share with other faculty members what students are saying, if for no other reason than for us to come together to find out how we can be more effective if we have to continue in this format. We don't want to stifle your learning. We don't want to stifle your creativity and ability to move forward. But I think that we're limited in this format, unfortunately. But still, give me those who came in late, Lex and I think Monier. Yeah, please give me a comment or two about what has been your experience, not necessarily only in my class, but just in general, if you've had online teaching and how you really feel about it. I know sometimes we are forced to do a certain thing. It doesn't mean it's our preference or we don't have any comments, about it. Okay, with that being said, then I'm looking for some other comments from those who came in late. You can do it at any point, just put it in private. Okay, so let me go back now to a problem that I wanted to review. And if you have this problem down pat, that's good. But if you do not, I want to talk about this problem. So let me do my new share again. Hold on. Okay. So let's look at a problem like number 13. Okay. Number 13. A tennis ball is thrown from ground level with velocity initial directed 30 degrees above the horizontal. If it takes the ball 5 seconds to reach the top of its trajectory, what is the magnitude of the initial velocity in miles per hour? So I sort of modified this problem a little bit because I want to capture two things here. I want to capture your understanding of two-dimensional motion, but also throwing in a conversion. And that way I do not have to convert, specifically talk about conversions, although early in the exam I will give this basic conversions, because what's going to happen here, class, is that if you can't solve the problem correctly, you will never be able to convert it. So that's why it's so important to be able to solve the problem correctly first, and then you will be able to convert it to miles per hour. So what's this problem asking us to do? I'm gonna have to do it the hard way only because I don't have any other option. So let me see here. Okay, so hold on, it was doing it earlier. Hold on, it keeps going and coming. So give me a chance to see if I can't get it to work a little better. Okay, I'm gonna start here, but then I'm going to go to the problem on the whiteboard. All right. A tennis ball is thrown from the ground, which means we're throwing it like this, okay, from the ground. And this angle here is 30 degrees. So now I know that my initial velocity is unknown, but it's directed at an angle of 30 degrees. Now, clearly, just from that, there isn't enough given for me to solve it just using a right triangle, because I don't have enough information given. Okay, I don't know. This is my hypotenuse. This is my angle. So clearly, that's not enough given. I need to know, either the y or the x or something else. So I can't use that. So now I go back to what else is given to me. It takes the ball 0.5 seconds to reach the top. So now I have time given, and that time is 0.5 seconds. and it's asked to find the initial velocity of the ball in miles per hour. So I chose this problem just to review, to let you see that at the end of this course, this is something that you should be able to do. So let's see what you're able to do. Now I'm going to go to the whiteboards where I have more room and we can have some interaction. So let me go to the whiteboard. I'm going to put this again on the whiteboard, okay? Okay, so I started by using this picture here. So now let's take this picture and use it to talk about this problem. And we're going to include some more stuff now. Okay, now I want to hear from you. How would you start this problem? Okay, if it takes it 5 seconds to reach the top, so I'll give this picture again. We know that when it is sent at an angle like this, that it has to reach the top, and then it starts to start its descent. So that we know, initial velocity. So this picture right here just represents this very beginning point. That's all this represents. Although it's big like this and drawn like this, it simply represents what happens initially. So this is now what I have to see in my mind when I see this picture. So when I see this picture now, all I know is initially it has some velocity and it takes it to the top in 3 seconds. So what else do I need to do? What comes to mind, class? How are you going to approach this problem? Someone can come on off mute and tell me, or you can type something in. Okay, so someone said the first thing they're going to use is the equation, the kinematic equations for constant acceleration. In other words, the object was kicked or thrown up and it reached the top. And what happened at the top before it began to descend is something was taking it up. At the same time, something was slowing it down. So much so that as it reached the very top, it started to fall back. So what we have learned already is that what goes up must come down. We've already learned that. And the initial velocity took it up to the top. At the top, the final velocity was 0. But in this motion, it's only 0 in the what? In the y direction. Because in the x direction, we have learned that there's no acceleration. Therefore, the velocity in the x direction remains constant. So all this has to be a part of what you are thinking about. So now you know that in the y direction, this final velocity in the y direction is 0. Okay? So now I can find the initial velocity in the y direction. Okay? And then once I find that, because we know how to use Pythagorean theorem, in other words, we already know that V initial in y is V initial. This is y, right? So this is what? Sine of theta. So if I find V initial in y, and I already know theta, I can find V initial. All of that is inherent in a problem like this. So this problem is requiring you to think. Not only that, you know what caused it to go to 0. And that was what? The acceleration in the y, which is negative 9.8 meters per second squared. So when you find v initial in y, it's going to be in meters per second, and you're going to convert that into miles per hour. Okay, so now what does that mean? That means then you have to know your equations. So do you know your equations for one-dimensional motion and straight up and straight down? Do you know those equations? And if so, you're given the time, you're given the final velocity, you're given a sub y, and you're asked to find v initial in y. So which equation would you use? So that means then, now I'll tell you what you're going to do, and we've done it so many times. You're going to have your equation quizzes right there in front of you. So you're going to, first of all, quickly eliminate the one that has what? X or Y, the displacement, because that's not given. And once you eliminate those equations, you're left with just one equation, okay? And that equation says what? V final in y squared is V initial in y squared plus what? That's 2ay. No, that's not the right one. I write it anyway. Because I was thinking about that. 2a sub y, but not that one. Why? Because we don't know what? We don't know why. So the other one says what? V final in y is V initial in y plus a sub y times t. That's the one we want to use. Because we know what? We know t and we know a sub y. And this is 0. So we can find this one. Okay, so let's work it very quickly. Let's see what my answers are. Work that problem. If you don't have your calculator and paper in front of you, go and find your calculator and your paper and pencil very quickly and come back, and then we will work on the problem. Okay. So we know then that V initial in Y, this is Y, hold on. Okay, let's see what I have. Anybody get? Okay, Nigel and Kaylin. Okay, now, thank you. So what you found is that V initial in Y V initial in Y is 4.9 meters per second. So now from this picture, class, I want you to be able to see, once you learn that the sine of 30 is always opposite over hypotenuse, and that the sine of 30 is equal to 0.5, then I want you to recognize that every time you have this number here, this number is twice that, okay? That's just what it is. It's twice that. It's 9.8 meters per second. And now you're able to convert that into miles per hour so quickly. So all of that is what this problem, a problem like that, is expecting you to know. Now, to me, that's deep level thinking, because you have to be able to think about all of that when you approach the problem. It's not just rote memory, but it's why it is that way. So I hope by reviewing a problem like that and showing you this chart that I'm trying to show you, let me go back to my chart. And I'm trying to show you that when you review this chart again, I'll give it to you again, that you want to recognize when you see the angle is 30. When theta is 30, that means that the hypotenuse is twice the opposite side without even having to do any work, okay? When the angle is 30. Okay, how about a 3? This is a 3, 4, 5. Okay, how I know that? Because I have multiples of 4 and 5. So the other one has to be a multiple of 3. So this then, if this is 80, this has to be 60. I didn't even do any work. I just know that it's 60 because it's a 3, 4, 5. And it's established. It doesn't change, class. Believe me when I tell you, it doesn't change. It is always that way. So if I had to fill out a chart like this, let me show you something that I hope you have learned. Let me put back to my pen if I can find my pen. If nothing else, if you're able now to quickly see this as being 60 miles, and this is my opposite side, which means that theta opens to the largest angle, then I can put my 53.1 here, okay, for my angle. And then I have the ratio of sine, which is opposite over hypotenuse. That's going to be the 4 over 5. This is going to be the what? The 3 over 5. And all that, I hope you're able to do quickly. Or when you see 1, 1 tells you that the sine and cosine are equal, which means it has to be that my angle is 45. Without any hesitation, you just know that. Okay? Which means that if this side is 10, this side has to be 10, and this side had to be 10 on the square root of 2. Okay? Those are just things you just have to know. If this is 100, the opposite side has to be 50. So those are the type of things I want you to know to take into what we do next. So if you have learned that, I feel like we have been successful, because so many students don't understand that. But not only that, this has to do with anything that's a vector. So when I say vector, class, this now applies to anything that is a vector. The hypotenuse, in this case, could be force. It could be acceleration. It could be momentum. Okay, it could be impulse. It could be anything that is a vector, because someone in the response told me that when they see this, they think about what we did when we did the part on adding vectors by the component method. And that was the whole purpose in doing that. So for my scientists and engineers and people who are going forward, when you get to your courses, or when you think about what you learned in vector analysis and having to do a hands-on type project where you're trying to find the tension, how much force is needed, this is a kind of analysis that you're thinking about. It's all can be shown using a right triangle, believe it or not. Of course, it's going to require a little more calculus than when you get down to the real stuff. But at its basic form, this is what you're doing. Okay, so that was the midterm exam review. Let me let me show you. Of course, this is back to our kinematic equations, which you have to be able to solve for the unknown. Okay.
Can we go back to the equation that we were just on and convert it to miles per hour?
Okay, very good. All right. So let me go back to share that screen. Okay, hold on. Okay. So once we get here to meters per second, then what you're going to do now is you're going to say, I have 9.8 meters per second. And also, before we do that problem, I want to give you a reference. If you remember, we solved this problem. I think we solved this problem. I can't recall now. I've solved it so many times. But the fastest man in the universe was Usain Bolt. And he was able to travel. He was able to travel the 100-meter dash in about 9 something seconds. Anyway, his average speed was about 10 meters per second. And that was approximately, we said, about 23 miles per hour. So keep that in mind. When you see these numbers, what do you all see? What do you all see? Let me stop. Okay, hold on. I hit my board. I'm not sure if I took it away or not. Do you all see where we have the triangles and the parabola? Do you all see that?
Yes.
Okay, all right. So with that in mind, then, when you're converting, you can convert these meters into miles, and you're going to convert these seconds into hours. But you no longer have to do all this. And the reason is because you know that this number needs to get larger in value, which means then when I say, in this case, I'm going to say 1 mile is 1.609 kilometers, and 1 hour is 3.6 kiloseconds. Now, watch very carefully what I'm going to show you right here. Whenever I want to convert meters per second to miles per hour, I always multiply by 3.6 and divide by 1.609. Now, initially, when I told you this, I want you to understand where this was coming from. But once you leave this course, I don't expect you to keep doing this every time. I expect you to know what that is. And in fact, you can even do the ratio. In other words, 3.6 divide 1.609 is 2.237. So if you were in the exam and you have memorized that number, 2.237, you can just simply say 9.8 times 2.237. And you have your answer, 21.92 miles per hour. Okay, so now you have your answer, 21.9 miles per hour. So to answer your question, in the final exam, I'm hoping that you have learned this and we've done enough problems to the point that even if you didn't remember the 2.237, which is a ratio of 3.6 divided by 1.609, if you didn't remember that, at least you would know to multiply by 3.6 and divide by 1.609. You see, at the end of the final exam, you do not have to reinvent the wheel because now you have learned this. So when you see that question, find it in miles per hour, your first objective will be to solve the kinematic equation. Make sure you solve for V initial, not for what and why, but you see this picture so you know quickly what to do. This number will be what? Double. And then this number will be multiplied by 3.6 and divide it by 1.609. Does that answer your question?
Yes, ma'am.
Okay. So now, by the same analysis that we just did, if I had this number I gave you a number in miles per hour, and I asked you to convert it to meters per second, you would do the opposite. You would multiply by 1.609 and divide by 3.6, because the numerical value in miles per hour, the absolute number itself, is always greater in miles per hour than it is in meters per second. You see the number. So that tells you then, if I'm going from meters per second to miles per hour, this number has to get bigger numerically, this part of the number. And the only way for it to get bigger is I multiply by the larger number and divide by the smaller number. On the other hand, if I want this number to go from miles per hour to meters per second, which is always a smaller number, I multiply by the what? Larger number and divide by the larger number. So I'm hoping that I'm telling you this now. I didn't tell you this initially because I don't want to, what they say, teach to the test. But after I've taught you this, I want you to know it. After I've taught it to you, now I want you to use it. Just like I said right here, once you see this is 30, I want you to know that whatever this number is twice that. I want you to know that now. After what? After having learned why it is. After having learned the chart and what happens with our trig functions and our Pythagorean theorem. Okay, any questions on that? Okay. Let me do a new share. Okay, so I'm going to put up for you, I'm going to put it on Blackboard, the midterm exam review, just to give you a chance to go through that again, because you see here, this object is moving in kilometers per hour, but the answer has to be acceleration in meters per second squared. So you want to be able to look at a problem like that. Okay. I had prepared another item, which I'm sorry, I'm just now getting to. Let me go back to what I prepared for today. Okay, so what I had prepared for today was beginning in chapter 11, which was fluids. So if you remember then last time, a question from someone? Okay, last time we discussed chapters, I think 5, 6, 7, and 8. And today I want to do a sampling of 11, 12, and maybe, was it 13? 11, 12, and let me see. Yes, 13. Okay. So that's kind of thrown in here. But again, all I want you to be able to do is know how to use your equations and what they mean. So this one is pretty basic. It says you're given the density, you're asking for the mass, so you know that you have to begin with the equation that says density is what? Mass per unit volume. And the units are kilograms per meter cube. So those are kind of problems you know how to do. Let's go down to one like number 4. Okay, number 4. We solved it before already. I want to just know, how are you solving this problem? What are you doing? So number 4, let's go to number 4. Okay, so you're given the density and you're asked to find the gold sphere whose diameter is given. So if I can remember these numbers, see the diameter is 0.25 And the density is 19.3. Okay, I'm trying to do that. Okay. Let me go to the whiteboard. Oops. Hold on. Okay. This stands for the diameter. Write that out. Okay. So we know the density of, so whenever we think about diameter, okay, first of all, we know that density is mass over volume. So we're given the diameter of something, and that's all we're given. We're not given the height. So when we see diameter, we think first of a circle, but there are two types of things that have a circle. We have what? We have a cylinder and we have a what? A basketball, right? So in this problem, then we have to assume that this is either a cylinder or a sphere. And the reason why we don't think it's a cylinder is because it didn't give us what? The height. So this is clearly a sphere. And they want to find the mass. So my mass then is my what? Density times my volume. And this volume is what? Of a sphere. So in just this one problem, I want you to know the equation for the volume of a sphere, which you will have written down. I hope it's on your paper. I can't remember if I put on there or not. 4/3 pi r cubed. So here, first thing you're going to do right here is what? Divide this by 2, and this becomes your what? Your radius, because that's what goes in this equation. So now you have your density and your volume is 4/3 pi r cubed. It's not a problem, it's easy to solve because you know what r is, you know what the density is, and you can just plug it in. So then I would expect you to put the numbers here, but rather than finding this number, you can do it all in one step. You can take 19,300 times 4 times pi, okay, times r cubed, and r is 0.25 divide 3. I'm sorry, divide 2. Cube that. You're going to get all that, and then you're going to do what? Divide everything through by 3. Okay? That's what you have to do. Now, the thing about it is this is a final exam. So this means this problem has to be done sort of quickly. So right away, you should recognize this equation. Now, I tell students in my physical science class, I say always visualize the equations that are so simple. They have 3 terms. So you have mass over volume, and that's what? And that's density. So that means mass is always density times volume. Volume is always mass over what? Density. And density is always mass over volume. Now, for my younger students, in my earlier first year physical science classes, I have them to think about this because a picture is worth 1,000 words for these young students. But for you, I want you to algebraically know what's going on, not just a picture. But it works for everything. It works even for sine of theta. So we say that sine of theta is what? Opposite over hypotenuse. That's what the sine of theta is, okay? So opposite is always sine of theta times hypotenuse. You can use it for anything. You can use it even for ones that have a little bit more data in them, okay? I'll give you an example. That's too small. Let me just, I'm gonna give you an example real quickly. I'm gonna clear this just to give you an example, okay? Oh, do y'all see the whiteboard?
Yes,
Yes.
ma'am.
Okay, good, okay. So I'm gonna give you one like this one, okay? Q is, we said MC delta T, okay? Now you say, but that's three things, but it doesn't matter. You can put three things there, it still doesn't matter, okay? In other words, Q equals MC oh, that's just too bad writing. Hold on, that writing is just too bad. MC delta T. So clearly, C is Q divided by M delta T. And sure enough, C is Q divided by M delta T. You see? Or delta T is what? Q divided by MC. And therefore, and delta T we know is always T final minus T initial, okay, which is Q over MC. In fact, we have a problem like that in the review. So again, this is just a way for me to help you to move faster through the final exam. Let me go back now to here. Okay. Let's see, I had a problem right here. It's pressure. Okay, we had pressure. We had pressure, atmospheric pressure, the temperature conversions. Oh, here we are right here. Okay. So let's look at this problem number 17. We've done it before, but I want you to do it again very quickly because I want you to be able to, if you see a problem like this in the exam, I want you to be able to do it quickly. So number 17, I want you to work it out and give me your answer. I want you to give me your answer with 4 significant digits. And that way I don't want A, B, C, D. I want your answer with 4 significant digits for number 17. When you get your answer, put it in chat. Number 17. We're all working on number 17, so I'm just waiting to get an answer before I say anything else. 4 significant digits. If you have a question or you're having difficulty, if you're challenged in any way, you can put that in private in chat. Because I have a part 2 to this question, so I'm waiting to get the answer. Okay, I've heard one comment. Okay, it's almost 2:30, so I'm gonna go ahead and go to share on this question. Let me go to okay. Okay, so where do we start? We're given the specific heat of ice. Okay, we were told the amount of heat that was removed. I think it was 50 kilojoules. Now, the first thing you got to know, class, is that when it's removed, we have to say taking it out. That's like subtraction. That's negative. We had a mass of, I think it was 2 kilograms, and it was originally at a temperature T initial of, what was that? 5, let me look at it again, hold on. Minus 5 degrees Celsius. Okay. Okay. Was at minus 5 degrees Celsius. Okay. So the first thing you want to do, class, is write down what's given in the problem. And once you write down what's given in the problem, these are your clues. You have heat exchange, which is Q. You have the mass. You have the initial temperature. So you see, I started working this out to show you how you're going to get to the final temperature. But then I went to a problem to remind you where it is you're going to use this. So T final then is going to be Q divided by MC plus T initial. Okay, so now solve the problem. You know Q, you know M, you know C, you know T initial. So what is T final with 4 significant digits? Now I got one comment and it said, I'm sort of stuck on where to begin. Now that's a very good comment, and I appreciate the student for saying that, because I want to point out to you in the exam, you have to know where to begin. And I'm stressing to you the beginning point right here. Begin with the given. Whatever's given in the problem, you write that down along with the units. That way you will have some idea where to start. If you don't know where to start, you're not going to be able to solve the problem unless, and I've changed the number, so you can't just go to Google and look up the same question. That's why I'm spending this time reviewing these concepts with you so that you will be able to solve the problem as opposed to just choose A, B, C, D without knowing where to start. So when you plug this in, you will get negative 50 kilojoules. You got 2 kilograms. And then C is 2.1 kilojoules per kilogram degree Celsius plus a negative 5 degree Celsius. Now what happens? Kilogram and kilogram cancel. Kilojoule and kilojoule cancel. It has to cancel. That way you're going to be adding degrees Celsius to degrees Celsius. And when you do that, you get the answer. So someone says negative 16.90. So you gave me 4 sig figs. I'm looking for sig figs in this answer. So the answer that I'm looking for, class, if I had to give you all the credit for that problem, would be negative 16.90. Okay. If I said 5 sig figs, you could put a 5 right here because it's a 4-7. So let's just say 5 to be on the easy side. Now, if I said negative 16.90 like that, it looks like 3 sig figs, doesn't it? What you're going to do, in order to make sure that I know this is right, you have to say something like negative 1.690 times 10 to the what? Well, this would be to the first, wouldn't it? So times 10 to the first. In other words, that 0 is there for a purpose, but I probably won't do that to you. I only want to make sure you plugged it in as opposed to guessing the answer. Now, this question may ask you now, okay, what is that for real that we can understand? In other words, this is in degree Celsius. In order for me to really understand that, I would rather have that answer in degree Fahrenheit, because degree Fahrenheit is more to my understanding. And here in America, I do not think in degree Celsius. I think in degree Fahrenheit. But we have an equation that says temperature Fahrenheit is 9/5 temperature Celsius plus what? 32. So now I even have a better understanding of that temperature when I convert it into what? Fahrenheit. So now, what do we review here? I want you to see, I want to remind you, because in the exam, if I say it's taken, the energy is removed, the heat energy is removed, I want you to be able to know that that means it's negative. So you won't get caught with just putting that number in without putting a negative symbol there. Okay. Okay, one like number 19. Okay, one like number 19. Let me pull up the, let me share again. Somebody having a little, have them, need to mute their microphone. Please mute your microphone. Okay, all right. Now, one like number 19. Okay, I said begin with what's given in the problem. So in this problem, you're given the specific heat of water, but you're given power. You're given the amount of the mass, and you're given delta T, and you're asked to find time. So again, you must identify what's given in the problem to determine what you're going to use to solve the problem. So in a problem like that, when I'm given, let me do a new share. Okay. What do you all see? The whiteboard?
Yes.
Okay, because I can hardly see it myself. Hold on. Okay. So in a problem like that, when you're given the power, okay, you get specific heat, you're given the mass, you're given delta T, so you can write that down for delta T, but you asked to find the time. So the one thing that comes to your mind for that problem is that power is always energy over time. So specifically, this is heat energy over time. So that's the equation you got to solve to find the time, because power is given. So you still got to use the equation for Q. In fact, this is still Q. All this is still Q, but now your objective is to find the time. So I hope that this review will help you. So what I'm going to do now is I'm going to send these sheets to you. I'm going to send to you these problems. These have to do with density, specific heat capacity, temperature conversions, pressure, volume, density, all those type problems. Now we've done these before, that's why I'm pulling these out for you to do again, just so you can, I guess, increase your speed in doing them. You know what I want you to practice it enough so that you know exactly where to start in the exam. So I'm going to send you this sheet. I'm also going to send you the midterm review that we did before we had the midterm exam, where you are going to make sure that you remember your kinematic equations, your equations for weight on the earth, weight outside the earth, force, which was this problem was tension, because all these problems are just thrown in there. Remember, it's comprehensive. So I need for you to be able to review this sort of quickly. Then also I'm going to share with you the actual questions that we had in an exam. I think we had an exam, maybe just a review. This is motion in 2 dimensions. Remember we had 2-dimensional motion, cars traveling and all that. I want you to review that too. Okay, if there aren't any questions, we can end there. That's all I had to share for today. If you have any questions, class, you can text me or email me, because I really do need to end kind of early today, just a few minutes early. But go ahead and sign your name as you exit. And if you have any questions about any of this, once I send it to you, start working on it, please feel free to give me a call or give me a text or send me an email. Okay, you may sign out now.